Okay, so in this lesson, we're still talking about quadratic functions. In particular, we're going to look at the information about the maximum or minimum. Now, keep in mind that when we talk about maximum or minimum, I'm going to do that here. When we talk about maximum minimum of the of a parabola of a quadratic function, remember that the maximum or minimum occurs at the vertex. All right, so the vertex, this is a maximum. Vertex, this is a minimum. So as we go through this, just keep in mind that the maximum or minimum occurs at the vertex. Okay. All right. So the directions, though, for this particular lesson is this. So an equation is going to be given. So you're going to be given a quadratic equation. And you're going to determine without graphing, so you don't want to graph it, just like we did in the previous lessons. You don't want to graph it, you just want to think about it. So determine without graphing whether the function has a minimum or a maximum value. All right, so we talked about that before, how to do that. Then part B, you want to find the minimum or maximum value and determine where it occurs. All right, so we talked about that in previous lessons as well. And then you want to identify the domain and range. Okay, so all of that we've done, but you're going to do this now without having to graph the function. Okay, so let's think about what this means. Okay, so let's look at this one. So your function is this. It is in general form. All right, so we need to know a, b, and c. So a is -2. So a is the coefficient of x squared. B is a +8. And c is your constant, which is a -2. All right, now remember part A says it's determined without graphing whether the function has a minimum or maximum value. Okay, well, to do that, to do part A, you're going to look at the value of A. So A is -2. Now what that means is that your parabola opens down. All right, so since the parabola, this is what you should be thinking. Since the parabola opens down, okay, it looks like this. Okay, it opens down. Then that means that the vertex here is a maximum. Your vertex is a maximum. So since the parabola opens down, the function will have a maximum value. Okay, so that's what you do to find it. So to answer part A, you think about whether it opens up or down. That's what you think about. Does it open up or does it open down? And that's all they want you to know for part A. Okay. Now part B though says different, so you got to do some computation in part B. Part B says find this minimum or maximum value and determine where it occurs. So what you have to do here in part B is actually, now remember the maximum or minimum always occurs at a vertex. So part B, you got to find the vertex. Okay, so that's part B, find the vertex. Okay, so the vertex formula, remember this is general form, so the vertex formula is -b over 2a, comma, f of -b over 2a. All right, so to find the x-coordinate, this says you take the opposite of b. Well, if b is a +8, the opposite of 8 is a -8. Over 2 times a is -2. So I get -8 over -4, which is a +2. So the x-coordinate of my vertex is 2. To find the y-coordinate, remember, to find the y-coordinate, you're going to find f of 2. So that means you go to the function, where we see the variable x, you plug in 2. So that's going to equal -2 times 2 squared plus 8 times 2 minus 2. And so 2 squared is 4. 4 times -2 is -8. Plus 16 minus 2. 8 times 2 is 16. This is 8. 8 minus 2 is 6. So I get the vertex being 2, 6. Okay, so once you find the vertex, then we answer part B. Okay, so part B says, first of all, where does the, in this case it's a maximum, where does the maximum occur? You're going to say this now. You're going to say, answer, you're going to say the maximum occurs at x equal 2. And the maximum value is, in blank, you'll say 6. Okay, so that's how you answer it. Answer part B. So part B, you have to find the vertex. Once you find the vertex, you answer the question. So remember, this is a maximum. So it's a maximum. So you can say the maximum occurs when x is 2, and that maximum value is 6. Okay? All right, now, here's how you're going to answer part C. Okay, so listen carefully to this. This is C. So C, they're asking you, in C, they want to know, identify the domain and range. Okay, now what I would do here is, remember in the previous lesson, when we found the x-intercepts, we kind of located where the vertex was, and we determined whether it went up or down the parabola. Do that here. So the vertex is 2, 6, so that's in the first quadrant. The parabola, remember, opens down. Looks like this. All right, and then here was the axial symmetry. Okay, now remember that was 2, 6. Okay, all right. So this right here is 2. So that's where the axial symmetry crosses the x-axis. It helps if you remember that. Okay, so that's 2, 6. Okay, so you're just interested in domain and range here. You're not interested in increasing, decreasing, just domain and range. All right, so it's very easy. Remember, the domain is negative infinity to infinity. And the range is, so you go from bottom up. So remember, these are arrows. So you go from bottom up, so you go from negative infinity all the way to this y-coordinate, the y-coordinate, which is 6. All right, so that's 6 right here. So I go from negative infinity to 6. So that's your range. Negative infinity to 6 with the bracket. Okay, so that was number 1. Okay, let's look at number 2. All right, number 2, you have, let's say this is our function. So our function is, let's see, our function is f of x equals 3x squared minus 12x minus 1. So f of x equals 3x squared minus 12x minus 1. All right, so again, let's denote A, B, and C. So A is 3, B is negative 12, and C is negative 1. All right, so to answer part A, remember part A, you want to know, without graphing, does the function have a minimum or maximum value? Well, to determine that, you need to know what A is. So since A is positive, the parabola is going to open up. So since it opens up, I'm going to have a minimum value. So it's going to be the smallest y value. All right, so since A is 3, which is positive, the parabola opens up. So the function will have, this is your vertex right here. So it's max. It's a minimum. So your function will have a minimum value. Okay, so that's what you do. That's how you answer part A. Part B is where you actually find this information. So you got to find the vertex. So part B, you find the vertex. So the vertex is negative b over 2a. That's your x-coordinate. Find your y-coordinate. You're going to find f of negative b over 2a. So, so the x-coordinate will equal, all right, this says I take the opposite of b. Well, b is negative 12. The opposite of negative 12 is 12 over 2 times a. A is 3. So I get 12 over 6, which is 2. So the x-coordinate of my vertex is 2. To find the y-coordinate, I'm going to find f of 2. So I go to my function, wherever we see the variable x, I plug in 2. So I get 3 times 2 squared, so 3x squared, so 3 times 2 squared minus 12 times 2, and then minus 1. So 2 squared is 4. 2 squared is 4. 4 times 3 is 12. Minus this is 24, minus 1. So 12 minus 24 is a negative 12. A negative 12 and a negative 1 is a negative 13. So my vertex is 2, negative 13. Once I find the vertex, I answer the question. So here's the answer. So remember the question was find the minimum value and then also state where it occurs. So we're going to say the minimum value. Oh, I'm sorry, this is this is minimum value. So remember that this right here, this is your vertex. Your vertex is 2, -13. Okay, so that's your minimum value. I mean your minimum point. Okay, minimum point. So this is minimum point. So we're going to answer the question. The minimum value is. It's not a maximum. It's a minimum. Minimum value is -13, and it occurs at x equal 2. All right, so that's part B. Part C. Part C. You want to find the domain and range. All right, so remember, all you do is this. So here's 2, -13. Oops, sorry, 2, -13. All right, let's find the domain and range. Well, let's do a little bit better job with this. So 2, -13's here. The parabola opens up, so let's go from there. Okay, that's 2, -13. All right, so domain. So remember, the domain of a quadratic function is all real numbers, so -infinity to infinity. The range, this is where you use your ruler and you go from bottom up. So I go from bottom up here. So I start touching the graph when I am at this point, and that's going to have a y-coordinate of -13. So I'm going from -13 all the way to infinity. So bracket -13 to infinity. All right. Okay, and then number 3, last one. Let's suppose we had f of x equals 5x squared minus 5x. So 5x squared minus 5x. Okay, so a is 5. A is the coefficient of x squared, so that's 5. B is the coefficient of x, so that's -5. And C, since there's no constant, it's understood to be 0. So that's understood to be 0 here, plus 0. Okay, now, A, to determine whether this function has a minimum or maximum value, and look at A. Since A is positive, the parabola is going to open up. Okay, since A is positive, the parabola is going to open up. So this is going to be a minimum point. Minimum point. Okay, so we're going to say this. So so the function has a minimum value. Function has a minimum value since A is equal to 5, which is positive. The parabola opens up. Okay, so that's your explanation. Okay, B. They want you to determine what is that minimum value and where does it occur. That's what they want to know. All right, so we got to find the vertex. So let's find the vertex. And you're going to need the vertex for part C anyway. So let's find the vertex. So the vertex will be -b over 2a, comma, f of -b over 2a. So the x-coordinate of the vertex will equal -b over 2a. So this says I take the opposite of b. Well, if b is -5, the opposite of -5 is 5. Over 2 times a is 5. So I get 5 over 10, which reduced is 1/2. Okay, 1/2. So far I get the point, the vertex, the x-coordinate vertex is 1/2. To find the y-coordinate of your vertex, you're going to find f of 1/2. Okay, now we have a fraction, so you have to be a little bit careful. Use your calculator if you need to. So we're going to say 5 times 1/2 squared minus 5 times 1/2. Okay? All right, at this point, I would just use a calculator. Now, my calculator, this calculator I'm using, it's not, you don't enter it the same way we do for the calculator you're using. So go ahead and on your calculator, write it in as you see it. You would say 5 times 1/2, close parentheses, then square, just like this. Then minus, subtract 5 times, and then 1 divided by 2, and then press enter. Okay, and that would give you a decimal, but you don't put a decimal here. you got to convert it back to a fraction. Okay? All right, so let's see if I can do it with this calculator. So let's see what we get. Let's see if this is going to work. All right, minus 5 times, nope. Okay, so I should have brought my calculator. All right, so let's see. All right, so this right here is 1.25, okay? Minus, and then 5 times 0.5 is 2.5. All right, so this is 1.25. Now, you wouldn't do this on your calculator because your calculator is easy to use with regards to this. This one's a little bit more difficult. So 1.25 minus 2.5, so I get 1.25. Okay, so as a fraction, that's going to be 1 1/4, which is 5/4. So make sure that that's what you got on your calculator. You got 5/4 when you did this. Okay. All right. So I get, this is my vertex. So the vertex is 1/2, 1/2, comma 5/4. All right. So make sure that's what you got. Now let's answer the question. So I'm going to answer the question next page. All right. So remember, the question was, what is the minimum value and where does it occur? And it's minimum, minimum or maximum. In this case, it's minimum. Okay, so we use the word minimum. Don't use the word maximum. Use the word minimum, because that's what it is. Okay, so the minimum value is, it's your y-coordinate now, 5/4, and it occurs when x equal 1/2. Okay, and that's all you do for that. And then for C, you want to find the domain and range. Well, the domain's easy. You don't even have to look at the graph. This is a quadratic function, a parabola, so the domain's going to be all real numbers, negative and infinity. Now the range, you need to look at what you have. So the the vertex, remember, is 1/2, 5/4. So that's in the first quadrant. And your function is going up. So it looks something like this. All right, so let's find the range. So the range, remember, you go from bottom up. Now remember, this is your smallest, the smallest y value here is going to be 5/4. Okay, that's what we found. All right. So remember, the range, you could look at your y values. So I'm going from, I'm going up along the y-axis. I start touching the graph when I'm at 5/4. And then from 5/4 to infinity. So your range will be bracket 5/4 to infinity. All right, and that was this. So we are done with this with graphing quadratic functions. All right.